Springs dessert. I think many people have commented already that this might be the first time that they've had the opportunity to check out this particular part of the venue. We've got with us lots of special guests today. We've got a special thanks to the folks with Autodesk. They're going to be here presenting a whole bunch of information for you. We've also got a lot of our esteemed colleagues and clients that are here today to talk to you about BIM. So it's great to see the reception of folks that have gathered today to join us. What's interesting about the crowd is we've got all sorts of disciplines and backgrounds covered today. There's in the audience civil engineers, architects, mechanical engineers, structural engineers, so construction professionals. So we're excited to bring a group of you together that maybe don't get to talk as much and talk about this new concept of BIM and its impact on your businesses. We've been talking for years and years about the concept of BIM, or about how BIM is coming, and eventually you're going to need to get there to be successful. But I think one of the messages for today is that BIM is here, BIM is now, and I think many of you are starting to be very successful with BIM. Others of you are just starting to get your feet wet with BIM, and so we're hoping to appeal to sort of the wide variety of folks that we have here today. And we're going to tell you about some technologies, we're going to tell you some success stories that we have, and we're hoping that everybody gains something out of their participation today. The other thing that we're hearing a lot is for the people that do have work, they obviously have a desire to be more efficient as they take that work through their organization. So again, I think you'll see us highlight a number of ways today that you can be more efficient as you work through them. And then lastly, I think we're here to gain a better collective understanding. This is the first meeting. We'd like to have further subsequent meetings. We'd like you to enjoy yourself. We'd like you to tell other people about it. We'd like to continue to build momentum. For Nevada to be successful in this building industry, we believe that BIM adoption is imperative. Again, I think you will hear a good argument that people have been successful.
Building geometry, spatial relationships, geographic information, and quantities and properties of building components. That is the stuff the building's made out of, how that stuff's put together, where it's located, the amount of stuff, and the nature of that stuff. Cool. But I really want to pick this apart a bit further on the next couple of slides.
So again, when we talk about building information modeling, we have to be careful that we understand fully what aspects of the project we plan to use for BIM and to what extent. This particular slide came from Penn State University, and this talks about all the different BIM uses that would occur during the project. So one of the things that, as you start to talk about BIM, you look at is the building life cycle. You look at the expense related to operating that building, not just the planning, design, and construction phase. So you can see here about 15 different uses, what they call primary uses for building information modeling. Those of you that have started into BIM are familiar with a couple of these at least. 3D coordination, for example, is one of the low-hanging fruit that I think many people have been exposed to so far. It was driven by general contractors, mechanical contractors. Depends on what kind of project, but let's say hospitals was a great place to start. 3D coordination is how can I put every bit of three-dimensional information together in a model, have that holistic model, and then start to look for clashes. And if I can find those clashes virtually, then what kind of payback can I get for the owner, for the design and construction team? We can look at reducing RFIs, we can look at reducing changeovers, and other constructability issues. Other things here that you'll see are different types of analysis that can be performed by different design professionals.
My pleasure to get in front of such a large group at a facility like this to talk about something that I'm very passionate about. And we'll see kind of through a little bit of my history how this has all come to be. But first, a quote from a rather renowned individual: never interrupt your enemy when he's making a mistake. And not too long after I saw this quote, I saw the following quote: that way it will become a bigger change order. Right? took off the name of the individual, but you can imagine that there are some market segments for sure that do benefit from mistakes that people make on their plans. Not the least of which perhaps are lawyers, right? But there's lots of other people that ultimately benefit from this. So let's keep that in mind as a foundation for what we're about to discuss. Just a touch about my background, as was stated, I work for Autodesk. I've been there about 4 years. The only thing of note that could perhaps benefit you as I go forward, I do have a blog, I Twitter, and YouTube videos, all related to BIM and specifically the product that I support for Autodesk. Okay, so my agenda will be to touch briefly on the traditional CAD and what its challenges are to business, and then BIM and its benefits as they apply to civil engineers, but also, of course, a lot of that will translate into many other market segments. Okay, so touching briefly then on traditional CAD. The history of CAD, and whether it was spelled C-A-D or C-A-D-D, often people refer to as computer-aided drafting, computer-aided design, or the double D, computer-aided design and drafting, was really not so much that, but the concept of computer-aided documentation. It was the attempt to recreate on the computer what we did via hand drafting. And often the way that came to pass is that the project's information was stored in a series of files. So I had a file for sheet A, or sheet 1, and a file for sheet 2, and a file for sheet 3. And occasionally the problem with that was when we had to make changes, particularly later in the design cycle, then what was required? It was necessary for everyone involved in that project, every person that touched those files, to make sure that they properly updated the files per the new design. 100% efficiency and accuracy was required. Now, being human, of course, that never happens, right? So it's not uncommon, ultimately, that there are some sort of errors and omissions that creep into our document set. And, of course, due to Murphy's Law, which of the drawings is that object and field going to be built from? The one that has the error on it. It's always the case. So, and then as my data as a civil engineer had been passed on to other disciplines, they could not immediately consume my data, so what did they have to do? They had to recreate my information in their systems, which again introduced the potential for error in just simply their inputting my numbers into their system, right? That's always a possibility. So there are some, ultimately, efficiency inhibitors in the traditional CAD environment. And their impact always were on the project timeline, the project budget, and or the design alternatives that I may study. And I'm going to point these two primary inhibitors at the moment. I don't know if in red they can be seen all the way in the back, but I have here a linear workflow and then erase and recreate. I'm going to take a moment to describe how these two particular phenomena impact what we do. And as an example, again, being a civil engineer, I'll use one of the workflows that I traditionally had, which was, if I had a surface, an existing ground surface, one of the things I had to do was to design a road. So I would create and define the alignment. Once I had the alignment, I would have to sample against the surface and that alignment. So I would sample a profile, a ground profile, basically. Then, once I have that information sampled, I could then create a ground profile or create a profile view. At that point, I may wish to sample perpendicular to the alignment and sample sections. And then I could drop in my section views. And then at some point, well down the road, I can create my own annotation to the process. Well, that was a finite period of time that it took to complete from step A to step Z. If I had an edit, or if I had a design change from whatever source, what would happen was, in the traditional CAD applications, I can't go back there and easily edit an alignment in some of the traditional civil engineering tools. So the process was, you would delete it, erase it effectively, and then create a new one. And then what would happen? You would have to step through the process from A to Z over again. And then create your annotation. And every time you had a design iteration, you had to go through all of these steps again. So ultimately, every design iteration, there was a finite period of time, or budget, or time with a timeline or budget, whatever you wish to call it, there was a finite period for every potential iteration. So it doesn't take much math to figure out, well, if it takes this much budget or this much time, over the entire course of my project, I only have so many potential design iterations that I can go through before I wear out my budget, right? But that's not going to complete the job for me. So I can only do so many and still accomplish the other tasks that are required to complete my project. Well, that's a challenge ultimately to being, one, sustainable. I can't go through all the potential design iterations I may wish to be sustainable and get this design appropriate. Now, additional challenges to business. Litigation, I mentioned litigation a bit ago, and as it turns out, and Joe alluded to this a bit ago, communication, a full 25% of all litigation in the civil engineering community was caused by poor communication. So I might have done something, I didn't convey that properly to someone else that it's critical in the design phase for this project. But then errors and omissions, almost another quarter of the potential as well. So between those two items, almost 50% of all litigation is caused by just those two simple items. Now there's a couple of other stats I'd like to point out. Again, I apologize for the small print. For those of you in the back, I'll go ahead and read this. It says as much as 30% of the cost of construction is wasted in the field due to coordination errors, waste of material, labor inefficiencies, and other problems. So here I have the quote. This was from a couple of gentlemen presenting to the CMAA, Construction Managers Association of America. And then separately, the Economist magazine a couple of years ago pointed out that inefficiencies, mistakes, and delays account for $200 billion of the $650 billion spent on construction in America every year. If we do the math, that's 30%. So that more or less jives with the typical, what percentage of a contract goes into contingency fees? Right? 25–30% is not an uncommon number. Right? People are trained to expect inefficiencies, errors, and problems. And that's a reality in every contract that exists. So as people address this, we talk about this concept of drafting-centric approach is often a very linear process. We understand the linearness of conceptual design, going to detailed design, going to construction documents, etc. But even within them, if I just focus on the detailed design, I have to do that design. Then I have to do the analysis. And then when I'm comfortable with that, I would more than likely then approach the concept of creating my documentation. And not until that stage, because again, a lot of that work could potentially be wasted. So BIM, Building Information Modeling, is one of the ways that people are using to address all of the challenges in business that they're experiencing. Now, it says building, so how does that apply to civil engineering per se? And a lot of people have chosen then, in other terms, as Joe mentioned, the concept of model-based design. And whatever works and what resonates most with any individual community or company, that's good. But how BIM, Building Information Modeling, has been associated with civil engineering, it's not building as in a physical structure, but building as in the verb, the act of building. Right? So anything that will be built and that we can create models that contain information is BIM. So from the civil engineering perspective, right away, even from the surveying and data collection, the fact that certainly LiDAR data capture has become such an important aspect of potential on a go forward. Many people are saying, okay, here's this point cloud. In essence, that's already a model. I can see it, it has physical attributes. I can understand, I can pull information, distances and dimensions and so forth from that. And take that model, like the cloud, and put it right into my design software. And from that design software, I can begin to do analysis. Right? You can't do that with lines, arcs, and circles and text. And then from that design model, of course I can create my documentation, which is so very important, but I can also create the visualizations. And then I can share that model with other disciplines so that they can use my model in their models to make sure that our models mesh and work together. And then lastly, we can take that model and hand it off to the owners for various reasons, not the least of which is construction. And one of the most commonly used examples of construction, model-based construction in the civil engineering realm is automated machine grading, right? GPS-guided machine grading. And I have a little example a little bit later that talks about the benefits of that. So, there was a document referred to as the Smart Market Report by McGraw-Hill that talked about many of the benefits for the various people that use BIM. And as I reviewed those, one of the difficulties that I saw for the civil engineers was a lot of these benefits were for well after I, as a civil engineer, was involved. So, reducing conflicts during construction, yeah, that benefits them, maybe not me so much. Right? And improved collective understanding of the design intent. That might be, again, further down the road. Improved overall project quality, reduce changes during construction, right? Reduce the number of RFIs, better cost control and predictability. Many of the benefits that are being touted are not so immediate to the civil engineer. But what the civil engineer has ignored, and often people say, well, we're not mandated to use BIM yet, so we're choosing not to go there. But what they're forgetting is that all those people, to gain all these benefits, they need models. And they're going to work with civil engineering companies that are providing models. Right? And if you're not doing that for them, someone else is. It's a simple reality of providing them the most value. Right? So we'll see another instance of that in just a moment. Okay, so back to the linear concept of the linear process. Traditional. We design, we analyze, we document. Well, now, in a model-based approach, or BIM approach, things happen simultaneously. And people begin to wonder, well, how is that possible? How can all of these three things be happening simultaneously? Well, I have a couple of examples. One, basically, in the newer design tools, one of the methods is that the newest tools use what's referred to as the dynamic object model. And within these tools, there are physical objects that represent intelligence. So we have a physical object referred to as an alignment. That would be this here. Physical objects that are parcels or surfaces. The survey object, the road, the pipe network, etc. These are physical things that understand what they are and how they're supposed to behave. So, as a brief example then here, I have a small video that talks about object modeling and how this all comes to be. Okay, so for those of you that are in front, you're going to be able to most tell this, and you can convey for those in the back what's happening. So from a simple design change of moving the profile, notice the structure is here. Right? But when that profile is moved, that structure is intelligent and says, my rim must be at that surface. So it grows automatically, and it grew over there in the top section as well. Now here, as that's brought back down, if we're looking over there in the top right, that road will drop down. What's going to happen to the structure? It doesn't stick out at the top of the road, it drops back down as well. It understands its relationship to the surface. If a typical section of the road is modified, and here we're going to widen a 12-foot wide road to 18 feet, if we're looking at some of the different components, what we'll see will happen, and was previously happened in that other example as well, here, in this case, the road is going to widen there. Right? We didn't see it, the quantities would have updated. The mass haul diagram would have updated, all as a part of the same process. As we take that manhole structure and move it from one section to the other, we're looking at the section over there, what's going to happen? It updates to the other side of the road. As we move that manhole structure off of that 2200 station there, what's left at 2200? Just the pipe and not the structure itself. Right? So the fact that as I'm working, as I'm designing, right, everything else is dynamically updating in the background. It lowers potential errors and emissions. It gives me significantly more design iterations than I would have had to have gone through in traditional methods where I would have had to have repeated all of the steps just to get to the same point where I already was. That's the significance. And that's what allows that simultaneous design, documentation, and I forgot my third one. Analysis. Thank you very much. Okay, so to continue. So there's plenty of organizations now that, and some of the earlier slides had some of these names on here. I wanted to point out a couple because they have impact as to what I'm doing. Certainly the General Services Administration, the biggest real estate owner in the world. They own all of the U.S. embassies. They're responsible for the Pentagon, right, all of these national facilities. The U.S. Army Corps of Engineers, in control of all the dams. The states of Wisconsin and Texas have mandated that all work being done on state facilities be done via BIM. Ohio has declared that they're having a BIM mandate forthcoming. And then within the last 2 weeks, or actually more like a month now, Australia has said that they fully support the concept of BIM. Haven't mandated yet, but they say this is the way forward and it's what's going to help our economy get out of the doldrums that we are currently experiencing. And then even after that, but perhaps more aggressively, the United Cape put out a report that said they are fully 100% behind BIM. They're going to approach it via a staged adoption process with fully mandated BIM by the year 2016 for anything related to government jobs in the UK. Okay. So, one focus then on one job in particular I'd like to point out. It was the Caltrans project for the San Francisco-Oakland Bay Bridge. They produced a video. I have the video, but I chose not to show it. It's about 5-6 minutes. But I took out some of their reasons why they chose a model-based approach for this particular project. Okay, so the first one, help design and plan construction for the project. So here are a couple of slides from that section. So they tried different design iterations, and I think the young man over here in the corner mentioned that he drives that bridge every day. And he had some interesting facts about it, and how this is all one continuous cable. There's no anchors to that cable anywhere. And how over the course of one weekend, a bridge deck was replaced. And I have the time-lapse photography of how they built a bridge deck on the side. They closed the bridge for a 3-day Memorial Day weekend 2 years ago, almost 3 years ago now. And then they ripped out the bridge section, existing bridge section, and then they rolled the new section in. All possible because they had rehearsed it all on BIM. Every contractor that was on the job knew what they were doing, and they had pre-visualized it already, how this was going to happen on the BIM model. And then schedule it. It also, they used it to educate the public and stakeholders regarding the project. There was plenty of pieces. You can't watch the news in San Francisco without seeing some references to either the Oakland Bay Bridge project or what's referred to as the Doyle Drive or Presidio Parkway projects. And the fact that they have models, they can produce many, or they repurpose the models for many different reasons. And then they've been able to inform and manage public perception regarding the project impacts. And one of them in particular had to do with a detour that's happening for the project. And they've been able to use those models so well, I should have had this up a moment ago, that they've even created an app. Can you see that? It says the Bay Bridge Explorer. So this app allows people to drive their detour right now. You can download it for free. And that's all because, and it was possible because of the model, right? It was repurposed. But what else is this? Right down in the corner, it has an engineering company that provided that model. That's PR. This is an Apple app that, people are dying to get Apple apps available. And here is free PR for that organization because they've been able to produce that model for Caltrans. So with that, just a couple more points. I mentioned the automated machine grading. Just a couple of facts. This particular organization was able to do a 4-acre section of a larger project in 2.5 days, which would have taken, I think, something in the neighborhood of 6 days to complete. Right? Yeah, it would have taken 6 days. They were consistently accurate with automated machine grading to 1/2 inch of plan, and that was 1/3 of the 1.5 inches that was required per their contract. So, then the BIM's return on investment, the bottom line, here this was from a report done by the Stanford University Center for Integrated Facilities Management, based on 32 BIM projects, 40% elimination of unbudgeted change, 80% reduction in time taken to generate cost estimates, accuracy of cost estimation within 3%, and it goes on and on and on. Ultimately, the bottom line, reduction of 7% in project time for most people that were involved in these projects. And in conclusion then, how do people win with BIM? What do they gain ultimately out of this? It boosts productivity, more iterations, design iterations, correct? It increases cost reliability, less clashes found in the field, that the model has all the components, and that allows us to code those up quicker. Build more sustainably with more design iterations, visually explore constructability. I can sequence that model, better predict and communicate project outcomes, downstream value to that data, and it ultimately does build closer business relationships amongst that community that has already been capable. Who are they working with? Only each other, because everyone else is not quite there yet. So for a business, ultimately it's less errors and omissions. I was going to put in here, and as a matter of fact, the first time I had this on the slide, one of these words was misspelled, because it happens. Errors happen, right? And this has the tendency to reduce those, and less financial risk, and ultimately less financial exposure. So changing the way we do business is essential to remaining competitive at the current stage that we're all working in. And that concludes my section. I would address any questions
as well. First, a little bit about me, Scott Davis. I'm an architect out of Southern California. Angel and I have been with Autodesk about the same amount of time, just over 4 years now. I'm known in the community as the Revit guy, because I learned about Revit the day it became available to the public way back when. It's actually been 11 years now, believe it or not, prior to Autodesk even owning Revit. I introduced it to my firm in Southern California. I worked for a firm called WLC Architects for about 8 years, and then left to join Autodesk because, like Angel, I'm very passionate about this particular technology. This particular audience, what we want to talk to you guys about all day long is the business value of BIM. So I was looking for examples of this, and I found one online. It's pretty recent, and it's a case study. So let me jump over here. I didn't get a chance to get Angel's little clicker plugged in.
There's one right there.
Which one?
To the right.
This one?
Yeah.
Does it have a key? Alright, there we go. This actually came from a website. This came from a website called the Revit Forum. Oops, I can't get to it right now. And I have a link at the end of it. But Martin is actually out of the Netherlands and has his firm and was really perplexed with how to get his firm to move over to BIM. They were a CAD-based workflow. They were using AutoCAD, and he was having struggles trying to convince the upper management why BIM and Revit in this case made sense. So this is from his website, from this blog post that he wrote. They proposed a contest internally. They picked a small but complex project. There were 2 teams assigned. It was Martin and his early adopter in their firm, who was a Revit user, and their 2 best AutoCAD users. Their fastest, best AutoCAD users. They were both given 10 business days to come up with a task, complete set of drawings, elevations, plan views, details, sections, construction documentation, building permit compliance forms, building code calculations, daylighting, ventilation, etc., cost estimates and quantities, sales drawings, and renderings as well. Along the way, they wanted to propose some design changes, but they didn't really want to tell the team too much about this, so they said after 8 days, structural calculations would be supplied, darn structural engineers, that would force some design changes to take place. After 3 days and 9 days, there would be a mandatory, but so far undisclosed, set of changes by the principal architect. So they're introducing some change in this. And Angel also mentioned the real power of BIM is not only the documentation in the first place, but the change management that happens. After 10 days, each team would grade each other's team's drawings. The ones with the least mistakes were crowned victorious. Overtime had to be logged. Each man-hour of overtime was counted as 1 mistake. So they basically went through and they counted mistakes, and they counted the hours of overtime on the project, and those were points. The Revit team won by 64 points to 3. The 3 points came from the fact that they had 3 hours of overtime, which was for a very long Revit rendering. So somebody had to stay in the office and tend to the rendering that was taking place. And probably the most compelling part of this is that the other team didn't even finish the second set of changes in CAD by the principal, nor the renderings, and I find this pretty funny, because they didn't have time to build the SketchUp model. Right? So they were building everything in CAD in 2D, and they were trying to run a parallel process, which was to build a SketchUp model to actually have the visualization and do the 3D at the same time. So that particular team is now fully converted over to BIM, basically convinced the principals in this particular firm of the business value of BIM. It was just huge, compelling reasons why they made that switch. Here's a source. It's actually on the redditforum.org if you want to go out and look for it. If you look for Martin de Vries with NDR Advies in the Netherlands, and you can find that post on there and read up a little bit more about it. So what I want to do next is actually jump into Revit, show you a little bit live, for those that aren't familiar with it, and how it works, and just some of the simple things that it does for enabling us to manage the change within our drawings themselves. Switch over, oops, my resolution changed dramatically. Zoom to fit. So first of all, in a Revit-based model, obviously we're doing things mostly in 3D. As we start to construct a particular project, everything we're placing, rather than a CAD-based workflow, drawing lines, arcs, and circles to represent objects, we're actually placing the real objects, or representations of those objects. So I place walls, I place doors, I place windows, and those objects all have intelligence. So the lowest hanging fruit of a BIM-based workflow is, of course, visualization, being able to show our clients models like these, and not only showing them from a 3D kind of exterior view, but even getting inside of it. So we can get inside of a model, we can zoom this one to fit, and we can use tools, much like video games, to stand in a particular space and look around or even walk around, and much like the video games, minus the machine gun, we get to be able to visualize the interiors, exteriors of our models. Much different than kind of the old school way of going into a client's office with a set of plans that might look like something like that and try to explain to them what the project is going to look like. So we're doing everything in 3D. Now, a couple things that I want to point out to you as far as change management in a way that Revit differs from a CAD-based workflow. And Angel hit upon this. In a CAD-based workflow, everything's done in separate drawing files. So like you mentioned, you have a drawing set for sheet 1, another drawing set for sheet 2, you've got DWGs for plans, other DWGs for sections, elevations, etc. And you have to X-reference all of that stuff together. And if you make a change anywhere in the set of documentation, it's our responsibility as humans to go back through and pick up all of those changes, right? Tremendous amount of time consumption there. Little things in Revit, it's a database-driven software system. Everything's included inside of one single file. So as we're looking at this 3D model, our plans, our sections, our 3D views, our elevations themselves, any renderings that we have, and even our sheets are all included inside of one single file. So anywhere I make a change, it ripples through the entire data set for me and updates all of that file. So for instance, if I go into one of our overall floor plans here and I start looking at this particular building section, I'm actually going to hit delete on the keyboard and get rid of that building section. If you look at my project browser over here on the left, I have no more building sections left in my project. Now in a CAD-based workflow, if I was a user and went into the directory and deleted all my sections out, somebody would probably kill me, right? Because it's going to take hours to recreate that kind of stuff. In Revit, since we have a live model, it's literally picking the section tool, picking 2 points through the model, and Revit creates the view for us. It's a live section looking directly through the model. Huge time saver, right? Always occurred to me, or always happened to me when I was in practice, that these kind of things were something that came up on a Friday afternoon. The principal would come up to me and say, hey, we've got a meeting Monday morning, and I need you to draw a section, draft a section, and Revit through that model for me. Oh man, it's going to be a long weekend. In Revit, I could do this all day long, and it was more not just for documentation purposes, but for just exploring our project. If I needed more sections through here, and I wanted to just start investigating the different kind of height relationships throughout the model, I could just draw one, grab it, use the copy tool, space out a few, and maybe just do 5-foot intervals. Oops, trying to go too quickly here. Copy that guy. I'm going to do it multiple times. I just drew 12 sections to the project. All of them are live representations of the project. Now, something else that used to get me all the time as a project manager at WLC was just now making sure that these particular callouts, whether they're sections, elevations, details, etc., actually pointed to the right location on the sheet. So, for instance, you notice all my section callouts right now have dashes in them. In an AutoCAD-based workflow, we used to put X's in these things. Anybody firm in here, you guys see X's in your detail callouts from time to time, right? And how many of you gone through a plan check and had a plan checker find one of those callouts, has the X's in it, and says, where does this detail go to? Does it point to the right thing on the sheet? In a Revit-based workflow, all of that is worked out for us, and this is just the way that Revit works. I have my sheet set up for my sections here. I can grab section 1, drag and drop it, place it on the sheet. You know what? That scale is not very good. Let me activate our view, and we'll change that scale to a quarter. updates all of my line work, all of my annotations, all of my call-outs, everything is scaled properly for the scale of the view on the sheet. No layers in Revit, no do we place everything on A-Ano-Dims for dimension, are my line weights correct, are the tick marks and my dimensions consistent from sheet to sheet, all of that is taken care of for us inside of Revit. And most importantly, since I've now dropped that on a sheet, the section marker just filled itself out for me. That thing alone originally sold me on Revit, right? Because now as a project manager, I did not have to go and chase these detailed callouts down. I used to spend countless hours every single day red marking drawings to make sure the details are pointed in the right location on the sheet. Now, as Angel said, changes happen. One simple change that happens in architectural practice all the time is that sheets get renumbered or reshuffled, or we have to add something. So if I go into this particular sheet, come down here, and we're going to make this maybe sheet 8404, guess what? Just updated my detail callout as well. So that change then ripples throughout the entire drawing process. Now, one other example of something that Revit helps with all of our documentation and change management is schedules. How many people in your firms like doing scheduling? Door schedules, window schedules, room schedules. You've seen them working. You guys have all done them before, right? You have your set of documentation on your desk, usually a ruler and a highlighter, so you can highlight off these individual rows of the corrections that you've made. And then you see people squinting at their screens all day long so they can get in close enough and zoom in tight enough to see those things. Schedules in Revit are just another view of the model. So for instance, here's a door schedule, just a text-based view of looking at the particular doors in our project. You notice that some of my numbers are a little bit out of order right now. I've done that on purpose. We're going to go ahead and renumber all of our doors in this schedule. So I'm just going to go 1, 2, 3, 4, right down the list. It's only going to take me a second. There we go, door 15. Now, in a CAD-based workflow, if I did the door schedule, what would I have to do next? Go back to every single floor plan, section, elevation, anywhere that I have those door tags, and make sure that the door tags were correct, right? In a Revit-based workflow, I just took care of that. It's all live data. I go back to my floor plans. All my door numbers are now updated for me as well. Let's hide some of these sections just for the time being. You notice that all of my door numbers are now coordinated with my door schedule. Vice versa. If I want to come in here and change door 13 to something different, go to my list, and we're going to make this one 23 for some reason. Apply that. I go back to my door schedule. Door 23 is right there. Right? So then I can set this up to resort for me and set that up accordingly. So that again is a huge time saver. The people in your office don't have to do form window schedules anymore. It's an automatic thing. They can concentrate on the design of the building, concentrate on making it work, making it flow, looking at those 3D images, looking at sections, looking at elevations, making sure that things fit. They don't have to concentrate on the CAD. They don't have to concentrate on creating your window schedules. Let's look at a window schedule here real quickly. Different view. I've actually categorized this to show me the individual window types. Right now they're done by 1, 2, and 3. Let's bring up a floor plan at the same time here. And we'll tile some windows side by side. Close out of that one. Alright, so if I zoom in a little tighter here, here's my windows, type 3, and that's actually wrong, right? So we should start labeling our windows by type A, type B, we'll make this one type C since it's 3. And you might have just saw what happened there. As soon as I do those, it's actually resorting my window schedule for me because it knows to sort them in alphabetical order. And my tags for my window in that particular view just updated. So again, something I don't have to go out of my own and manually coordinate. Revit takes care of those things for me. Again, it allows us to concentrate on the design aspects of the project. Now, there's so many other benefits of having a model. Angel showed you a few of those, from making iPad apps to using the model for facilities down the road. In Revit, it's about being able to start analyzing these models. So we, in Revit 2012, have an analyzation tab that allows us to start looking at energy settings of buildings. So we can start putting in some ideas about what this energy model consists of. And then next to that button at the top, we've got the ability to analyze these models, which pushes them out to the cloud, allows us to do energy diagram, we had the three bubbles where design and analysis and documentation were going on at the same time. As an architect in practice, we typically did energy analysis near the very end of the project, right? And typically we didn't do it. Our electrical engineers and our mechanical engineers did it, and they wanted us to be about 95% done with CDs, right? Because why? They were scared to death we were going to make a change, and they had to redo all those calcs all over again. Well, now we as architects can use a tool like these analysis tools directly inside of Revit, and from the moment I start, I can put an enclosed space on a set of drawings, and 4 walls and a roof. I can run an energy analysis on it. So I can start making those design decisions when they make the most impact, which is at the very beginning of the process. So hopefully that gives you guys a great sense about how Revit can be helpful. You saw the case study about how the team won over their office. They showed a 64-3 gain in their point scale and won their office over from a CAD-based workflow to a BIM-based workflow. And hopefully I've shown you some examples here, just some very simple examples. It's the little things that add up. The big picture of Revit is very powerful, and that's why I'm very passionate about it. But it's all of these little things that tend to add up that will start costing your offices so many countless hours of changes, and just the fact that the coordinated changes inside of your model here don't worry about it. You can catch them ahead of time and be more productive and have better coordinated models. All right, so with that, I'm going to then turn it over next to our MEP representative, William Spier. He's going to come up and show you some of the BIM aspects of Revit MEP.
Am I on? Loud, good? Okay. I'm pretty straightforward anyway, so I need a mic. But it's good that we have one. Well, let's see. Good morning, everybody. Everybody enjoying the show? Yeah? Now we're going to get to really cool, exciting stuff. Mechanical, electrical. Wow. All right. So, a little bit about me. My name is William Spier. I'm an MEP technical specialist with Autodesk. I've been in the industry 17 years now. Cut my teeth at an MEP firm, consulting engineering firm in Seattle, Washington. Did a lot of work on Nordstrom stores by and large. But everything came across my desk. Schools, churches, hospitals, you name it, we did it all. Became a project manager for a lot of Nordstrom stores over that was bulk of my work. Left there, went to work for Johnson Controls in Pennsylvania, doing O&M work for Merck Pharmaceuticals. So I went from the design side to the operation and maintenance side. And when I finished school, I left there and went to work for Midwest Mechanical Contractors in Kansas City. So I went to the contracting side. And we did by and large hospitals and ethanol plants there. I did the coordination work on those. So I got to go from design, operation, and maintenance to the contracting side, where I got a set of drawings in a couple weeks after I was there, and then looked at them and said, that's nice. We rolled one through in the corner and said, all right, let's start over. How many contractors do you need? Yeah, so, okay, you know what I'm talking about. Said, what are you doing? I said, go ahead and try and build it from that, right? They weren't using BIM at the time. So, that's a little bit about my background and my experience. What you're looking at right on the screen now is Revit MEP, and just a little breakdown for those of you. In fact, before I go further, how many people in the room have worked on a BIM project with Revit? Okay, the rest of you not. All right, how many engineers do we have in the room? Okay, anybody in the room that's interested in energy analysis, energy design, whether you're an architect, energy analyst, mechanical engineer, hands up? Okay. All right, the rest of you take a break. All right, so 3 flavors of Revit. 3 flavors of Revit. Our Revit architecture, which you just saw a minute ago from Scott. Revit MEP, which is what I'm going to show you, Revit structure. And the way they work together in a nutshell is simple. The architect, typically, and the structural engineers will get together and they'll both create a model. And they're going to create the models based on each other's work. So they're going to link them together, not unlike X-referencing in AutoCAD. So each can see what the other's doing live. They can stay at each other's hair. A structural engineer puts a beam in, he can locate that against the wall, and Scott moves the wall, the beam will move with it if Scott allows it. So as they go back and forth, they get updates and saying, this is moved, you want to accept the change, reject, and so forth and so on. The thing that's nice about Revit is that it allows them to do that much earlier, much faster. They can build models quickly. Anybody that's done Revit in this room will attest to that. So if you think I'm kidding, ask anyone in the room that's done Revit, you'll understand how fast this goes. What that does for me as a mechanical designer is it allows me to bring my skill sets to the table much, much earlier in the project. Because before, as Scott said, when we get designs way late in the process from the architect, and frankly, we'd rather have them way late in the process because we're going to work out all this analysis, and then Scott's going to go make a change, and what happens to my design? Let's start over again, right? Well, now, as Scott makes changes, I can just roll with the punches, and I'm going to show how some of that works real quick here in a few minutes. So I went back to the owner and said, look at what we did. And the owner said, this is fantastic. I want you, architect, and I want you, MEP firm, on every one of my data centers going forward. The architect was livid. Why? Because the architect doesn't understand that this is going to be a collaborative effort. This is a collaborative environment. Because we all want more jobs, we want repeat business. So we learn to work together in this environment instead of the old school, which is that proprietary nature that we're used to. What are we going to get? We're going to get more jobs, we're going to become more productive. I'm going to be able to use my skill sets to provide a better result for the owner. So Revit is not unlike Excel for any of you who've been watching this. In Excel, if I go into Excel, what is Excel? It's a database, right? If I'm a financial guy, I punch in a bunch of numbers, and I want to see what those numbers look like in a pie chart, all I do is press a button. I don't hire a drafter, and I get a pie chart, right? And if I change the numbers, the pie chart changes too, so it's accurate. I can't even fake it. So if I change the pie chart, the numbers will change bi-directional. The only difference here is that this is a building information model, and that's a financial information model. Isn't that a model of my finances? No. So if I take a length, a width, and a height, and I say, this is a WALL, a wall, and it has this U value and this R value, I now have got a model with information that I have built, right? So it's no different. When I show that piece of information, I can show it as a pie chart section, or I can show it as a number. In Revit, I can show it as a number, or a wall type, or an actual piece of visual wall, right? So it's still the same piece of information displayed in different ways. That's all Revit really is. And there's 3 flavors of Revit, so today we're going to look at Revit MEP. And what I was going to do is I was going to kind of take you from the more mundane to the intergalactic, so to speak. But Scott really kind of covered the mundane part of it, which is, it's good. Not the boring part. What's the mundane stuff we do? Going back and checking to make sure that that section view number was right. I was actually going to show you that, but Scott showed you that, right? And when does that count? When we got 30 minutes to get the project plotted down the board. And what do we normally do in AutoCAD? We're going to open that file, make sure it looks right, then close it. Not in Revit. As soon as you make the change, I don't need to go to these other sections and views and whatnot, make sure they're right. I already know what's changed there. I don't have to open and refresh, right? So he's kind of covered the mundane, which is good. So, yep, I'm going to go head towards intergalactic right off the bat. So, let me go and switch views here. Yeah, now it's driving to the projector. Yeah, no, it's not changing. So,
More dilithium crystals.
what's that?
More dilithium crystals.
Yeah, that's what I'm trying to do. Get it to intergalactic speed too. Yeah. Alright, so instead of picking and clicking, I'm going to talk through these a little bit more instead. One of the things I talk to people about real quick and easy to understand is if you're going to do a project, a lot of projects we do now, in fact the majority of the projects we're doing today are on existing buildings, right? Bringing them up, retrofitting them and so on. So as a plumbing designer, let's say, I'm asked, hey, we've got this building, we've torn all the walls off, but we've checked a bunch of things, we're good to go, we're going to do a lead interior on this project. Why not add some value to the owner? Is there anything we can do plumbing-wise, right? So typically we look at low flush fixtures, and whatever kind of things we can do quick and easy. One of the ones we overlook a lot is gray water systems. And so I talk about a gray water system when it comes up. Yeah, it's pushing new projectors. I think it just closed my computer. So anyways, if you're going to do a gray water project, you have to do 3 things. You have to do something with the building, you have to do something with the information, and you have to model it, right? Building information modeling. So what am I going to do? I'm going to go in and I'm going to take a look at this building and I've got all this plumbing exposed. I can create a gray water system pretty easily just by creating a new system that's going to be a containment system for it, so I can do some remediation with it. But I can turn that into irrigation water, I can use it for a cooling tower, a number of different ways you can use it. But it requires me to go in and actually track some information. Because if I have the best gray water system in the world and I have no information to track it, how many leak credits do I get for it?
I think I better know mine. I got a big mouth. So I'm going to actually do things a little different. I'm going to talk about a couple of case studies. We're going to take a trip to Miami Valley, Ohio, and then we're going to take a little trip to somewhere in North Carolina and talk about a couple of different projects. Look at some of the benefits that everybody's going to talk about today, some of the ROI of BIM, and then go from there. Hopefully that's okay with everybody. Who's heard of the Miami Valley hospital that Skanska and Shook kind of did? No? So people always ask me what product we use, so let's just get that out of the way. It wasn't just an Autodesk BIM project. Microsoft involved, there was Autodesk, there was SketchUp, there was Graphisoft, there was a little bit of everything used on this project. A lot of Microsoft. So let's clear the air on that right now. So they modeled everything, down to the patient rooms, down to the MEP racks, and that's really what we're going to focus on for this particular case study. So let's start with the patient rooms, a couple of things. So they actually modeled the patient rooms, one for buying. Who's built a hospital in the room, or designed a hospital? All right, I'm really short and can't see, so be proud. Put your hands up. So if you've ever built a hospital, you know that you got to talk to the doctor, you got to talk to the nurses, you got to really get buy-in, especially for the head wall units. Where are the placements of all the things? But you're going to go through actual mock-up, and they really leveraged BIM for the actual patient rooms. And they built all the physical mock-ups, they brought the doctors and nurses in, and they got buy-in. That was important. And also during the existing hospital renovations and things, they took a lot of surveys and asked the patients, what are some things that are important to you? The patient said, well, I don't like dark hospital rooms. And I also don't like walking from my bed to my bathroom when I'm in pain. So they really used BIM to say, well, what are some things that we can do? We can reduce travel distance to the toilet. That would be good. We can also make our rooms brighter. So they kind of changed the shape of the hospital rooms into the kind of weird design of the hospital room. Then they started thinking about, well, what else can we do? Let's fabricate. Let's start looking at ways that we can break these hospital rooms down and fabricate the actual pieces. Put them in a warehouse and ship them out to the job site. Kind of a unique concept. So they started breaking these hospital rooms down into individual pieces. So they broke them down into a toilet room module and actually fabricated everything inside the toilet room module. They broke it down into a head wall module, fabricated everything inside the head wall module. Now that took a tremendous amount of buy-in, a tremendous amount of modeling, a tremendous amount of mock-up to get to that point. And then the casework module on the right side, whew, sweet. So really cool concepts, a lot of models, a lot of BIM. And then they said, okay, what are we going to do with it? Now we've got a model. Let's put it on a truck. So they were able to take 4 complete model sections, built sections, fabricated sections, place them on the truck. Let it do BIM. Conceptualizing it before it's ever built. Cool stuff. So what else did they do? And they were able to study the MEP racks. Bring all the 5 major trades together. MEP, fire protection, all those guys all together and fabricate the racks into 16-foot by 5-foot by 5-foot sections into a warehouse. So now you're moving from overhead work into warehouse work. Now you're safer, you're managing your risk better. And so think about that. And plus in Ohio it snows. I mean, I know you don't get much of that here in Vegas. Once every 2 years you get a couple inches of snow. Kind of a scary thing here. In Ohio you get a lot of snow. So now you're fabricating your, I guess I'm talking a lot like a joke. So I don't like using these things. So in Ohio, they're able to fabricate these MEP racks. Better coordination, a lot safer. So let's take a look at these. So we've got our MEP racks in the top left. We got some piping getting installed on the bottom left. The actual trades working together on the upper right. And I think delivery on the bottom right. What do we have now? Some statistics. So on an average job like this, with 5 different trades, throughout the course of the project, you're going to have 100, 120 different people working on a job throughout the course of time. This job was reduced down to 18 people working in a shop. Think about the labor savings of that. Super significant on a construction project. Also, the labor rate was reduced from $50 an hour to $40 an hour. That would make me happy as an owner. Being able to save money, 20% savings. What else do we have? So, conventional job, you're able to lay 200 feet of pipe in a day. This job, 600 feet of pipe. Why? Because I only have to go over here, grab my pipe, walk back, and install it in my rack. And I'm also not working overhead, and I'm not having to bend over as much. And I'm also everybody's working in the same area. This one's really important to me. When I was working in construction, safety was our number 1 priority. No injuries on this job because everybody's on the ground, not climbing up and down ladders, working in the same area. Plus, you only have 18 guys. It's pretty System leaks. Being able to find, locate, and repair all your system leaks early. Being able to ship out stuff that you know is absolutely going to work. I think that's pretty valuable. Hey, work. So, being able to shorten the job. They originally planned, I think, a 2-year duration on this project. Being able to shorten it down to 1 year. So, a couple of images of the actual fabrication. Boiler rooms getting ready to be fabricated. Toilet modules getting ready for delivery. These are actually fabricated modules. Head wall units. Patient rooms getting ready for delivery. I think these are pretty important. These are the actual toilet modules getting ready for installation. And then they use these loading platforms that actually set out about 7 feet from the building, and they can just pick them up and move them around so that they can put the toilet modules in place, and they basically set them on these big giant skateboards and wheel them around, make them easier for installation. And they coordinated this building so well, wow, my West Virginia accent really comes out, doesn't it? So well, we'll try again. They have the depressions in the floor, and they basically treated them like Legos. Set them in place, move on to the next piece. So, some of the statistics. So let's move on to North Carolina. And actually dive into Navisworks, a couple screenshots out of Navisworks. So this project, the first couple slides that we're going to look through, we took it to model bit, was using traditional methods. No bit. Drawn using AutoCAD, coordinated using regular methods. The architect drew it over the wall, contractor don't see me, fine, whatever. Drawings were sent out to the fabrication shop, steel erector erected the items, no problem. Slab was poured throughout the building, no problem. EMP was added. They started on the 5th floor, we're going to work their way down. Once they added EMP, and they really did go this far on the job, they noticed a problem. I'm 5'5", and I could reach my hand up and touch the bottom of the EMP. Does anybody think this would be a problem with the construction site? So they didn't actually add the ceiling, but we added it for visual scariness. So less than 7 feet in a construction site. So $60 million project. They fully erected the steel. They fully poured all the slabs on all 5 floors, and they hung the ductwork on the 5th floor before they realized, we've got a problem on our $60 million job. Oops. So they fired the contractor, fired everybody else. All kinds of lawsuits started going around, delayed the job about a year. And there was a contractor that came in and said, hold on, I think I can fix this for you. Give me $100,000. And I'm going to go model this. I've got a structural engineer that I want to work with, and I think we can solve your problem. We're not going to do anything else but examine it. They explored a lot of different options, including tearing the entire project down. They've already invested a ton of money. Well, who wants to tear down an existing structure? I sure don't. So they actually modeled the entire remodel with a structural engineer, looked at it, and came up with a solution. And this may be one of the only jobs I've ever seen do this. Are there any structural engineers here? You? Well, this might be a scary thing for you. They cut a hole in every single piece of steel. All of it, so that they could put the ductwork and piping and everything through all of the steel, so that they could keep their ceiling heights at a cost of $10 million and an additional delay of 6 months. So 18 months goes by, $10 million on a $60 million project. So as a structural engineer, is that scary? Might be a little scary. So